For this project idea, we are going to do a pedestrian detection for automatic vehicles or a person detection. So for the code, you can see on the screen, we are using simple image download. Simple image download is used to download images from the net. You can see I have already downloaded the images. So first we will install the simple image download library and then install simple image download and save. So here are the earlier images I downloaded for reference, and here are the images that I have downloaded. People walking on the street. It will be useful for pedestrian detection like this. You can see. Now what we will do is we will download this as a zip folder to be used in LabelImg to label the images which are important for YOLOV8. Here I have opened Anaconda prompt, and in Anaconda prompt I have already opened my environment, that is new YOLO that I created for the code. Here first you need to install LabelImg. For my case I have already installed LabelImg, so it will say the requirements already satisfied, as you can see here. Now you download it on your local device and in Anaconda prompt, and now you go to LabelImg. After entering, you will open a page like this. From here, go to OpenDIR, open your own file where you have saved the images. In my case, I have saved in a file which I'll open like this. I have opened it. Now change it to Pascal to YOLO, and by clicking create a rectangle box, you could create a rectangular box around the people, right? And now a window will pop up. You enter which class name you need to give to people. For my case I have used person, so this is the person that we will detect, creating a bounding box. In change save directory, you could select a folder to save these labels. In my case I have used my local directory itself. So next image, I do the same for everything. I used person as a label, use another person as a person. So person is a class here that is going to create a bounding box name above it. That is the class given to person. So I'll perform for all the images and meet you on the other side. So for this code I have here installed, first we'll use YOLOV8. I have created pedestrian detection. In case of YOLOV8 you need to create libraries like this, libraries or folders like this, where train and validation. The train images will contain all the images, and validation images will contain 10 to 12 images and labels from train. So here labels signify the LabelImg text file that we created, that are the labels and images, and the label images. Classes.txt is directly created, and here data.yml file. In data.yml file what we do, we use train validation number of classes, that is NC, and names person. In train we give path to the train dataset, and validation we give path to the validation dataset. In validation dataset, the data that we have in train, so the images, 10 images from validation, 10 images from train images, and 10 images labels from train labels are saved in validation as a validation score. Okay, now here is the part to it, number and names of the class, right? And this is the txt file that is directly comes after we complete labeling into our label local file that were saved label after labeling, right? So this is done. Now for this code we install ultralytics, that is the library where YOLO is saved. In my case I've already downloaded, so requirements already satisfied. Now from ultralytics I import YOLO, and model is YOLOV8.pt. So there are multiple YOLO models like YOLOV8.am, S, N, X. I've used medium, which is fine for case of explaining. Now for the code we will use model.train. Data is equal to, we will copy the path of data.yml file that is to be given, and we give number of epochs to be given. For my case, I'm using 10 epochs only. If you want high accuracy or if you want to train your model for a longer time, you could higher number of epochs. We could give batch size or number of workers we need. So let's keep worker as 1, and image size, that is 640, given to you by YOLO itself. In YOLOV8 GitHub, you could see YOLOV8 GitHub. I'll put the link in description. So here we use, okay, so for this code, in place of predict, you will need to write train. I've done a mistake. In place of predict, write train. See, now I'll add train. Window like this will appear on your screen. It will download the data. Yeah. So the training has started, and our runs folder will be created on the left side. On files, you can see a directory, or runs, where all the data that you have saved will appear, that has come from training will appear here. So it is running. It will take some time to run, no big deal. As we can see, the number of epoch running has started, so it will take. And the training starts now, and after the training is done, I'll meet you on the other side. Now for the record, see how data is created in weights, and we will use best.pt, that is the best weight or the best training batch that has come out of the data. These are all the matrices that we receive along with the data that is being saved. Now for the code, I have downloaded the best.pt. You can use Colab as well, but I wanted to show you proper images of the data, so I have got you to Jupyter Notebook, where we'll import YOLO from Ultralytics. Then we'll use base.pt that we have got from these weights into our local Jupyter Notebook, and we'll use source as predict.jpg. Here we have trained the model and got the output jpeg predict. Now we'll run the code, and this is how the output comes. This is where the output is actually saved, and this is the output. And now I'll run the model. So if you go to your local device, this is how Jupyter Notebook looks, and you'll need to find a file named runs.